And you can kind of see the mechanism and how that's going to rotate around there with this little kind of helix that goes around there. And so this is a four-axis arm. And the idea of forward kinematics right now is, you see what I have with this arm is that I have a location here in space. And we can read out that location space. There's an X, Y, Z location. Now, if I reset everything kind of to the zero position, we see we get what looks like some, fairly straightforward, nice numbers. X is 650, Y is 0, and Z is what, 407, okay? And that basically is measuring the distance from some coordinate system here to there. And I can go ahead and do that. So if I go ahead and measure, I can say, yeah, let's kind of go from origin to origin here. Let's go from this origin out to that origin there. And that's what you measure. So that's the distance to the X, that's the distance in the Z, and there's nothing in the Y because this is lined up perfectly symmetric, and that's Y. Pretty much that's the X, Y, Z, or Cartesian location at the end. And if I manipulate one of these joints, move it around, obviously the position of that coordinate system now changes. And so I can manipulate it, of course, interactively here just by grabbing something, or I can go to my slider here and move them around, or I can go ahead and say, oh, just put in, a clean 90 degrees here, and maybe a clean 0 degrees there. And let's see where it is. And of course, what's going to end up happening, you shouldn't be too surprised, is that when I rotated this 90 degrees and kept that at 0, the X is now 0 degrees. But the Y is 650. Because remember before, the X was 650. Yeah, that makes sense. All it did is just take the arm and rotate around 90 degrees. So in many cases, it's nice to experiment with this thing to build your internal intuition of what you expect is going to be going on.